And we are now recording. Okay, so while I'm setting up the shared screen, I plan to have today's session very similar to yesterday's, where first half I'll lecture, and then second half I'll make it a question and answer session, almost like an office hour. If anybody has any questions about the test, and if you don't have any questions, then you can just be dismissed. Okay, and then tomorrow, however, I'll lecture just as I normally do for exam days. I'll lecture, quote unquote, a very short time, and then again questions and answers, and then we break, and then we take the test. Okay, so our usual rules apply. So right after class is over today, you may start submitting your homework if you wish. I don't want homework too early, but once the day before the class ends, then you can start submitting your homework. So after class today, you can start submitting your homework if you have it. Okay, so I'm going to lecture on 11.7. I probably won't finish it. So this will be first half. Second half, questions and answers pertaining to the test, which means you ask me stuff from where'd it go? From here, 9.1 to 10.2. This is what you submit for homework. Again, you must submit at least 70%, but that's really a joke since I end up doing a huge percentage of that. Sometimes I end up doing 70% of the homework. Okay, but if you don't turn in the homework at least 70%, then I don't grade your test. It counts as a 0. Okay, you can have one cheat sheet, front and back, 8.5 by 11, double-sided, anything you want. And you can have your calculator, but beyond that, no other books, notes, people, internet, cell phone, and so on. Okay. I'm not sure when I can give the date for the last exam. It'll probably be somewhere here. Okay, when I get close enough to it, I'll let you know. But be ready, be flexible that the exam can be any of these days, hopefully. Okay, so I'll lecture on 11.7. And when it gets to be near noon again, we will quote unquote break. But if you have no questions, you can just leave. Second hour, like yesterday, will be dedicated for questions and answers. And if you don't have any, you can leave. So tomorrow I'll lecture a little bit more, questions and answers, then break for 10 minutes, and then take the tests as we normally do for exam days. Okay. All right, so that's it. Otherwise, I'll get started with, well, marked it down over here. So 11.7. So I'm done with this. So 11.7, I probably won't finish it, but that's okay if I don't finish it. All right, so any questions anybody has? Let me check the chat. Okay, and thank you, Star. Star put something in the chat. Please read what Star has to say there. And I believe Mackenzie also sent something through Canvas announcements because I got it. Okay, so please take advantage of Star and Mackenzie. It's optional. You don't have to. You're not going to get bonus points or brownie points for that. And you can always come to me, of course. You can stay the second hour for questions and answers. You're always welcome to come to my office hours. You can always email me anytime. But it's optional. If you don't think you need it, you don't have to. Some of you doing fine. Some of you, if you need extra help, please take advantage of Star and Mackenzie. They're there to help you. That's what they're here for. And I'm here to help you also. Okay. All right. So I think I'm caught up from the chat. Let me see what we have here. Yeah. So I think we're good. So let me get started with 11.7. And it's still considered review, I think, just a little bit of new stuff. But we're graphing inequalities in the plane now. Okay, so 11.7, 3 to 33. So let me go straight to showing it to you, page 832, for those of you who don't have the book and aren't getting it. Okay, so this has the purpose of showing you what the problems are like. They're inequalities. I see greater than, less than, greater than, equal to, less than, or equal to. Okay, so you've seen some of these, but probably in a linear context. Now we'll have some situations where it's not linear. And then we have systems also. And some of the harder ones, as you can see, are here. Okay, so I think from the text book, you can see everything that we have here. All right, so how do you do these inequalities? So 11.7, page 832. Graphing inequalities. Okay, minor, anything that I'm lecturing on today will not be on tomorrow's test. It'll be on our last test. Okay, so you definitely have seen linear inequalities before. That's 3, 5, 7, 9, 11. You've probably done some systems too, like the harder ones, 23, 21, and so on. You may not have done non-linear ones like 13, 15. Okay, so I'll show you many of those. So let's start off with number 3. 2x minus 3y is greater than 6. Okay, there's more than one way to do these. Okay, so I'll show you a way. If you're used to seeing it another way, that's perfectly fine. Okay, so you might recall that if I have a greater than situation, it's a dotted line. If I have greater than or equal to, it's a solid line. So I'll start off with this. If you have this or this, you would have a dotted line. That means points right on the line do not satisfy the inequality. If you have this or this, you have a solid line, right? So that being the case for this situation, right? Do you think that would be a dotted or a solid line? It would be a dotted line. Okay. If you had the underline there, it'd be a solid line. Okay. And again, if you want, you can put that in your cheat sheet, not on the cheat sheet for tomorrow, but the last cheat sheet, the cheat sheet covering our last exam, which is all this stuff. Okay, so first thing I'm going to do is graph the boundary line. So I'll go like this. So for the boundary line, I could make this look like y on one side and mx plus b on the other side. That works. And if you're used to that, that's fine. For something like this, I think it's easy just to pick the intercepts. Like what happens when x is 0, figure out the y, and when y is 0, figure out the x. Okay, if I put a 0 right here, 2 times 0 is 0, temporarily pretend it's an equality. Negative 3y equals 6. If I divide by negative 3, then y is negative 2. So 0, comma, negative 2. I'm trying to get the boundary line. Now, how about y equals 0? Put a 0 here. That makes this 0. Wipe it out. 2x equals 6 means x is equal to 3. All right, so I have my intercept 0, negative 2, 3, 0. I connect it with a dotted line. Okay. Now, you might recall the way it works. I either shade this half plane or this half plane. Okay. The entire XY region is called a plane, P-L-A-N-E. This is a half plane. This is a half plane. So how do you know which side you shade? You can pick any test point, test it. If that point works, you shade that side. If it doesn't work, shade the other side. Normally, the easiest point to pick is 0, 0. So plug in 0, 0. If I get a true statement, shade that side. If I plug in 0, 0 and it doesn't work, I shade the other side. Okay. So my test point will be, in this case, the origin. Okay. Why the origin? It's usually easy to plug in. I would always pick the origin if allowed. And by the way, you say, when is it not allowed? Well, if the line happens to lie, if the origin happens to lie right on the line, you're not allowed to pick the origin, then you have to just move off. Okay, plug in 0. 2 times 0 is 0. 3 times 0 is 0. 0 minus 0 is 0. 0 is greater than 6. 0 is greater than 6. Is that a true statement? No, that's false. That means 0, 0 does not work. So I shade in everything else over here. So that's my solution set. So every point down here works. Every point here does not work. And points right on the line do not work either. Okay, so let me just say 4, 0. 4, 0 should work. 4, 2 times 4 is 8. 8 minus 0 greater than 6. Yes, that works. But 2, 0 should not work. Plug in 2 and 0, 4 greater than 6, that's false. Yeah, so I know I shaded it the right way. Okay, so remember doing stuff like this, right? Hopefully. 2x minus 3y is greater than 6. Okay, now with that in mind, I'm going to quickly show you number 5, which is just a slight variation of it. Two x minus 3y is greater than or equal to 6. Look what they have here. 2x minus 3y is greater than 6. This is the same thing, except there's a line underneath it. Can you guess what happens to the graph? It's the exact same graph, except instead of a dotted line, it's a solid line. Okay, so I don't have to run through the analysis anymore. I'll just graph the exact same thing, except it's a solid line. Which means points right on the line do satisfy the inequality. So it's a very simple graph. Just graph the same thing, essentially. Let's see, 0, -2, 3, 0. But instead of a dotted line, it's a solid line. And still shade below. That's it. Because all the math will be exactly the same. Okay, so 2x minus 3y greater than 6, strictly greater than, dotted line. Points right on the line do not satisfy the inequality. 2x minus 3y greater than or equal to 6, that's a solid line. Okay. A point right on the line does satisfy the inequality. So if I plug in the point 3, 0, put a 3 here and a 0 here, right? It would say 6 is greater than or equal to 6. That's true. Over here, it would say 6 is greater than 6. That's not true. And that would be true for any other point on the line. So any point on the line would not satisfy the inequality. It would say 6 is greater than 6. But 6 is greater than or equal to 6. So points on the line do satisfy the inequality. Okay, so that's the only difference there between the solid and the dotted line. All right. Okay. Number 9. X is greater than or equal to 1. Okay, solid or dotted line? Solid, there's a line underneath it, right? Do you recall the graph of x equals 1? That's my boundary line. X equals 1 is a vertical line. If you have x equals a constant, it's a vertical line. Solid. Quick note. How would this inequality change if I was going to make it a dotted line? What change would I make if it was a dotted line? How would I change this inequality? Instead of greater than or equal to, it'd just be greater than. And it's a dotted line. Okay, pick a point on either side. You're not allowed to pick a point right on the line. Okay, but pick something here or here. Whenever possible, pick the origin. 0, 0. So plug in 0 for x and 0 for y. There is no y to plug in. So just plug in x. 0 is greater than or equal to 1. That's false. So I must shade the other side. So there we go. Okay, now if I got a true statement, I would shade in the side with the origin. But it looks like in the cases I have so far, I do not shade that in. Okay, that's that. Any questions so far? I don't see anything in the chat, so we'll just go on. All right, so I believe so far, this is all review. You've seen this before, but what's now new is nonlinear stuff like 13, 15, and so on. Okay, so let's see how to do some of those. Y is greater than x cubed plus 1. All right, first, do you think it's solid or dotted? Dotted. Only it's not going to be a line, it's going to be whatever the shape is. Okay? So we're reviewing from a long time ago. It's nice to sneak in a little review for the final, because the final exam, you might recall how to do stuff like that. So it's going to be dotted, only it's not going to be a line, it's going to be a graph. Okay. Now, do you recall y equals x cubed? Y equals x cubed is a cubic like this, but I don't want to draw it because it'll clutter out the picture. But it goes something like this. Okay, I'll fake it one more time, sort of like that. And then do you remember what's the effect of the plus 1? Move the graph up 1. But the graph is dotted, dashed, because I don't include the possibility of equality. So here's what I'm going to do. Something like that. Okay. See, it's exactly the same concept as over here, except that it's dotted. Okay, so I'm going to shade either this side or this side. Pick the origin, it's the easiest. 0, 0. 0 is greater than 0 plus 1. 0 is greater than 1. False. Origin does not work. So it's everything over here. Okay, so instead of a dotted line, it's a dotted graph, as it were. Okay. $15. X squared plus y squared is greater than or equal to 25. X squared plus y squared greater than or equal to 25. Okay, solid or dotted? Line underneath it, solid. Okay. Do you recall x squared plus y squared equals 25? Circle. Center the origin. And do you recall what the radius would be? It's not 25. It's the square root of 25, which is 5. Radius is 5. Okay, so I'm going to have a closed circle, okay, not dotted because I have that line there. Okay, circle, center of the origin, radius of 5. One, two, three, four, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Center of the origin, 5 to the left, 5 to the right, 5 up, 5 down, solid. Okay, question, what happens if I didn't have that line underneath it? Dotted circle. Right, so there's two regions, either the inside or the outside. So pick a point either inside or outside, see if it works. Okay, again, whenever you have a chance to pick the origin, do that. Plug in 0, 0. 0 square root of 0, 0 square root of 0, add them up 0. 0 is greater than or equal to 25. False. So again, the origin does not work. So it's everything on the outside. If the origin worked, I would shade everything on the inside. That's my solution set. Okay. Points right on the circle themselves do work. So for instance, 5, 0. Put a 5 here and a 0 here. 5 squared is 25. 25 plus nothing is 25. 25 is greater than or equal to 25. That's true. How about inside? 1, 1. 1, 1 does not work. 1 plus 1 is 2. 2 is greater than or equal to 25. That's definitely false. But how about a point over here like 0, 6 should work? Put a 0 here, a 6 here. 6 squared is 36. 36 is greater than or equal to 25. Yeah, it definitely works. Right. Any questions so far, please? Okay, then the rest of the problems are systems. It's definitely harder. So it's not just one inequality. They might give you 2 or 3 or 4 or a whole bunch. Right? Look at 33. It looks like they give you 6 of them that all have to be satisfied at the same time. Okay. So let me start off with the linear case. Oh, I guess they don't give us any linear cases. So never mind about what I just said. Which one looks like the nicest one of 17, 19, and 21? I'll try 21. X is greater than or equal to 0, y is greater than or equal to 0, y is less than or equal to 1 minus x squared. Okay. So these are harder. These are my guess. All right. This is a system of inequalities. That means they give me more than one. All of them have to be satisfied. Imagine they're joined with the word and. X has to be greater than or equal to 0, and y is greater than 0, and y is less than or equal to 1 minus x squared. Okay, so in red, I'll put and that's the implication. So even though it doesn't say it, they all have to be true. So x is greater than or equal to 0, and at the same time, y is greater than or equal to 0, and at the same time, y is less than or equal to 1 minus x squared. Okay, by the time you get to something like 33, where there's 6 of them, they all have to be true. So for 33, it's the first one, and the second one, and the third one, and the fourth one, and the fifth one, and the sixth one, all the way through. All right, by the way, this looks like what some word problems are like, right? You can imagine some word problems, okay, we don't want any negative for x. That's what x is greater than or equal to 0 means. We don't want any negative for y. There's something about the demands of the word problem which say x and y have to be greater than or equal to 0. So this implies first quadrant, right? Quadrant 1. So anytime you see this combination, x is greater than or equal to 0, y is greater than 0, it's first quadrant. Although, yes, you are allowed for the x and y axes, that portion of it. Okay. So I see that in problem 31, x is greater than 0, y is greater than 0. 33, x is greater than 0, y is greater than 0, or whatnot. Okay. So those restrictions have to be taken into account. Okay. So essentially, I just have a first quadrant view. Okay. And a quick word, all 3 of these are going to be solid or dotted. They're all solid, right? They all have the line underneath it. So anytime you see this, I can immediately draw the following. So here's the shortcut. It's basically that, right? That's included, that's included. So my graph is just going to be first quadrant. X is greater than or equal to 0. That means over here. Y is greater than or equal to 0. That's over here. So now I mess with this. Y less than or equal to 1 minus x squared. Okay. Do you recall the shape of this thing? Parabola. Opening up or down. There's a negative. Goes down. So if it just was negative x squared would be like this. Okay, maybe I'll just sneak this in. Negative x squared. Then what's the effect of the 1? Move the whole graph up 1. And yeah, there's a piece over there, but we already know we're not counting it. Y equals 1 minus x squared. 0, 1, 1, 0. How do I know it's 0, 1? Well, what do you get when you plug in 0? 1. How do you know it's 1, 0? What do you get when you plug in 1? 0. Okay, so I know I have this side, and now I shade either above or below that parabola. Pick a test point, like the origin. It's nice. 0, 0. Whoops. 0 for x, 0 for y. 0 is less than or equal to 1 minus 0. Is that true? 0 is less than or equal to 1 minus 0, which is 1. 0 is less than or equal to 1. That's true. So this is my region in question. That's it. Okay. Which essentially means x is greater than 0. That's all this. To the right of this line, y is greater than or equal to 0 above the x-axis. So has to be to the right of the y-axis, above the x-axis, and below the parabola. So here's the region in question. Everything here satisfies all three of them. So offhand, I don't know, 0.1 comma 0.1 would work. 0.1 greater than or equal to 0, yes. 0.1 greater than or equal to 0, yes. And well, this is a little bit harder, but that's going to be, it's going to be true. 0.1 is less than or equal to 1 minus 0.1 squared. Yeah, I'm pretty confident that's going to work also. Okay. All right, so that's what we're up against. Okay. 19. Y is greater than or equal to 1. Y is less than or equal to square root of x. It's interesting. Solid, solid, right? They both have the line underneath it. Do you recall the graph of y equals absolute value of x? Then you don't need it for tomorrow's test. You'll need it for, well, this test and the final. It was V-shaped, wasn't it? Absolute value is V-shaped. Okay, so it doesn't have to be that exact a graph. We'll just crudely draw a V-shape. Do it right, sorry. Okay, do I want above or below that? Okay, so this is where I'm not allowed to pick the origin because the origin is already in my solution set. It's on the graph. So I have to pick a point that's off of the graph. So I can't pick 0, 0. No, how about 1, 0, like over here. Okay, so I'll try 1, 0. If it works, shade in this region. If it doesn't work, shade in this region. So 1, 0. 0 is less than or equal to absolute value of 1, which is 1. 0 is less than or equal to 1. That's true. So I'll be shading below, but I'm not really going to do it yet because I have to wait and see what happens over here. So instead, I'm just going to draw some arrows indicating I want to be below the V shape. So imagine I'm shading everything below the V shape, but I have to wait until I analyze y is greater than or equal to 1. Y equals 1, horizontal line, you might recall. Change colors, red. Y equals 1. Okay, if possible, ignore the V right now. Focus only on this. It's either going to be above or below. This time I'm allowed to test the origin. Okay, so yes, I've already shaded the V shape. I've got red arrows going down, but now ignore it temporarily. Pretend all you see is y equals 1. I'm either going to shade above or below. This time I can pick the origin. Now the origin is not allowed for the absolute value function, the V shape, but it is allowed here. So plug in 0 for x and 0 for y. There is no x, so don't worry about it. Put a 0 here. 0 is greater than or equal to 1. That's false. Origin does not work. So I'll draw some green arrows above. Okay, now what's my final answer? The region that is twice shaded, the region that has both red and green. Can you see what it would be? It has to be all the points below the V, imagine below the V, below the red, but above this line. Okay, so it looks like I would have everything here and everything there. So that's my region. Okay, so again, it must be below the V, but above the green line. So that and that. Okay. A little bit tricky. Okay, then I'll try 17 for you. Y is less than or equal to x squared. X squared plus y squared is less than or equal to 1. Okay, solid, right? Both solid. I think I'll start with this one. X squared plus y squared equals 1. You might recall that's my unit circle from trig. Nice little review for the test. Right? X squared plus y squared equals 1 is my unit circle. Okay, so it's either going to be inside or outside. Pick the origin. 0, 0. 0 plus 0, 0. 0 less than or equal to 1. True. Inside. But I'm not committed to shading it yet because I have to wait and see what happens for this. Y equals x squared. Parabola. Opening up. Vertex of the origin. So now ignore the circle. I know it's kind of hard. Ignore the circle. I'm either going to be above or below the parabola. This time I'm not allowed to pick the origin 0, 0 because it's on the parabola. So just move off. Like 1, 0, 0, 1 or whatever. How about I pick 0, 1? So x is 0, y is 1. 0 squared is 0. 1 is less than or equal to 0. 1 is less than or equal to 0. That's false. So I want below the parabola. So now I can see the region that I'm shading. It's got to be inside the circle, but below the parabola. Both have to be true. So can you see what that region is? Below the parabola, inside the circle. So there we go. Okay. All right, then these ones at the end, fortunately, they're mostly linear, but they got a lot of stuff. Give us a whole bunch of stuff. But notice like 23, 25, if they immediately say x is greater than or equal to 0, y is greater than 0, you know in the first quadrant. We're definitely in the first quadrant. Okay, so 23 and 25 are very similar. They give you two other lines. So I'll just graph those two other lines, and I'm in the first quadrant. Okay, so how about I'll do, let's say 23. I'll let you do 25 on your own later. Uh, 23. Y is less than or equal to x plus 5. Y is less than or equal to negative 2x plus 14. In the same space, I'm going to write the next two off to the side. X is greater than or equal to 0. Y is greater than or equal to 0. Okay, so again, just like over here, this means first quadrant. Very practical for word problems, right? So you know for some word problems, you don't allow for any negatives for X or negatives for Y. Okay, everything's going to be solid, 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 solid. So I'm going to immediately draw my first quadrant view. Right? And oh boy, this has a y-intercept. These both look like y and mx plus b. That b is 14. Okay, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7. How do I know to stop to 7? I know when I plug in 7 here, this will be 0. So anyway, well, this looks a little harder. Let me get this out of the way. So 0, 14. And I said 7, 0, right? All right, so am I above or below this line? So shouldn't I keep going there? Yeah, technically the line keeps going forever, but I already know I'm in the first quadrant, so I can just do this. Okay, above or below the line? Pick the origin, 0, 0. If 0, 0 works, below. If 0, 0 doesn't work, above. 0, 0. 0 is less than or equal to 0 plus 14, which is 14. 0 is less than or equal to 14. 0 is less than or equal to 14. True. Below. So how come you don't shade it completely right now? Because there's stuff to figure out this one. Okay, y is less than or equal to x plus 5. That's easy. Y-intercept is 5. Change colors here. 1, 2, 3, 4, 5. Well, slope is 1. So over 1, up 1. Okay, and I know the picture is getting cluttered now, but only look at this line. I'm either going to be above or below that line. So pick the origin again, 0, 0. If it works, shade that side. If it doesn't work, shade the other side. So 0, 0. 0 is less than or equal to 5. 0 is less than or equal to 5. That's true. Okay, so can you see the region that I have? It must be in the first quadrant, below this line, and below this line. So I have this funny shape. It's a quadrilateral four-sided figure, right? So now I can commit to this being the graph like that. Okay. All right, maybe I have time for just one more. 29 and 31 look very similar. 31, you know, in the first quadrant, and everything's dotted. 29, you're not necessarily in the first quadrant. It just says y is greater than 0. So let's just see what happens. Okay, so I'll do 29. Five x plus 6y is greater than 30. Oh, I'm sorry, less than 30. My bad. Less than 30. Y is greater than 0. Let me get y greater than 0 out of the way. Y is greater than 0. That's quadrants 1 and 2, right? So I can ignore this part here. Ignore 3 and 4. And it's dotted this time. Now I've already graphed the x-axis. Y equals 0 is the x-axis. So I'm just going to draw it a little bit above or below like that. So I don't know if you can see that red line I have here. It's supposed to lie right on the x-axis. Okay, this one, well, why don't I just pick the intercepts? Okay, x is 0, forget about it. 6y equals 30 means y is 5. Plug in y is 0, forget about that. 5x equals 30, 6. So 0, 5, 1, 2, 3, 4, 5, and 6, 0, 1, 2, 3, 4, 5, 6. So connect it with a dotted line. Like so. And test the origin. 0, 0. If 0, 0 works, below the line. If 0, 0 doesn't work, above the line. Put a 0 here. 5 times 0, 0. 6 times 0, 0. 0 plus 0, 0. 0 is less than 30. True. So I'm below the line. Below the line, but it has to be greater than 0. So I'm shading all of this stuff. Unbounded region. Okay, I'm just about done. I will just quickly mention 31. 29 and 31. 31, they add an extra x is greater than 0, which means I'm only in the first quadrant. So if I'm only in the first quadrant, you just have that. So you just have the triangular region. Right? So I'll just mention 31. Same as number 29. But first quadrant, because it says x is greater than or equal to 0. So a very crude graph is you only have that part. You only have this part here as your solution. Okay, I'm done for today, folks. So let me check the chat real quickly. I have nothing else that's there. Okay, so it's our quote unquote break time. So if you have no questions, you're free to leave. For those of you that want to stick around and ask questions, I'll start up again as our usual time around 12:10. Tomorrow I'll lecture a short time, questions and answers, break, and then we take the test. Okay, and if you want to start submitting the homework, you may submit the homework also. Okay. And let's see, can you type your homework? Yes, you still are allowed to do that. That should be fine. Okay, so break or leave, that's perfectly fine, up to you. Okay, so if you want to stick around, you can. I'll start up at 12:10, but if you want to leave, you can do that too. All right. Okay, Justin, this is supposed to be the time for questions and answers. So if you have any questions, you can bring them up now, but if not, the class is over. Okay, so just let me know if you have any questions. If not, we'll just close the session.